never happened before. They were a witness to history, and they experienced that.
That's beautiful. This has got to be one of the most proud moments of my life, I guarantee you.
By the sixth moon landing, American astronauts had become experts in planetary exploration.
Have at it.
The technology to work, move around, and survive outside a spacecraft had been tested and refined. But human ventures beyond the Earth ended with Apollo 17.
When Apollo ended, I think technologically we were on the threshold of developing a capability to go to Mars. Matter of fact, Jack Schmitt and I said when we came home that by the turn of the century, we'd be on our way to Mars. But we couldn't gin up the spirit of the country to move on and to press on at that point in time. And I think people, in essence, I hate to say this, but, you know, almost lost interest.
I think we probably optimistically felt, well, bring on Mars, we'll take that on, we can do that. And since then, I think we've found out that it's a little bit more involved in doing that.
On the 20th anniversary of the first moon landing, Mars loomed like the next frontier.
From the voyages of Columbus to the Oregon Trail to the journey to the moon itself, history proves that we have never lost by pressing the limits of our frontiers. We must commit ourselves anew to a sustained program of manned exploration of the solar system, and yes, a manned mission to Mars.
NASA's plan called for launching over 1,000 tons of materials, fuel, and supplies into orbit on dozens of rockets and assembling them in space. But the plan soon ran into trouble.
The problem with the NASA plan was they had to build a giant spaceship because they were bringing out to Mars all the fuel and oxygen they needed to come home. That was 80% of the mass they were sending to Mars. Now, in fact, it never got out of the dock because it was so expensive with a cost estimate of $450 billion. The Congress refused to fund it and the program was killed.
To get the mission back on track, Bob Zubrin and fellow engineers at Lockheed Martin Astronautics came up with the idea of making fuel for the return voyage on Mars. Their goal was to use the Martian atmosphere for raw material, something that they could simulate in the lab. To convert the atmosphere into fuel, they chose a simple chemical reaction that's been known for over a century. Then they built a prototype to see if it would work. One chamber of the machine is filled with an absorbent powder that could literally soak up carbon dioxide from the Martian atmosphere. In a second chamber, the gas is mixed with a small amount of hydrogen, the only raw material that would have to be brought from Earth.
And they will react to produce methane, natural gas, great rocket fuel, and water.
The water is sent to a third chamber where electrolysis produces the oxygen that's needed for burning methane fuel. A small machine like this could supply all the fuel and oxygen needed for the return voyage from Mars and for powering a surface vehicle. Every pound of hydrogen brought from Earth could produce 12 pounds of methane and oxygen, allowing Mars pioneers to live off the land.
Instead of having to launch a 1,000-ton spaceship into Earth orbit, you launch maybe 200 tons. And maybe you do that in 2 launches, each of 100 tons. Hey, we had boosters that could do that 30 years ago, okay? If you adopt this approach to Mars of living off the land, it basically means we can do the mission with the technology we have now, or frankly, the technology that we had decades ago.
The Saturn V boosters that launched Apollo back in the 1960s, each capable of lifting over 140 tons, are ideal for launching a Mars spacecraft into Earth orbit. But the only Saturn V's left today are museum pieces on display at NASA space centers, so production would have to begin again. An alternative is the slightly less powerful Russian booster, the Energia. Test launched twice, the factory that built it still exists. Or the shuttle booster could be modified to launch a Mars vehicle in 2 or 3 pieces for assembly in space. A small reusable rocket NASA is currently developing would require more trips, but could be less expensive. The same upper stage rocket that took Apollo to the moon could be used for the journey from Earth's orbit to Mars. Returning from Mars is where Zubrin's machine comes in. He would split every Mars mission into 2 launches in a plan called Mars Direct.
In your first launch, you fire off to Mars an unmanned payload consisting of an Earth return vehicle. Okay, this is a little rocket ship that's going to be used to fly back from Mars to Earth with a crew of 4 astronauts in it, but no one's in it right now. It flies out to Mars unfueled. Its fuel tanks are empty. And once it's landed on Mars, it makes the fuel and oxygen it needs to come home. It takes perhaps 5 to 10 months to make the fuel. Of course, the people on Earth have monitored this, so long before the next launch window opens up, we'll know we have a fully fueled Earth return vehicle waiting for us on Mars.
The crew would land their spacecraft within a few miles of the return vehicle. When the time came to leave, it would be abandoned. Because Mars Direct is economical, NASA mission planners like John Connolly embraced the idea with only a few changes.
Morning, everyone. Hello, John. Understand you don't like us staying on Mars for 500 days. You want to go shorter.
The major change was to put a large return spacecraft in Mars orbit so that when the crew blasted off from Mars, they could transfer to something with a little more legroom. But the basic idea of living off the land had taken hold.
When we're going to Mars, we're going to start thinking again like the pioneers did. We're going to start using the land for our subsistence as much as we can. If you think about the early pioneers that pioneered the American West, they didn't load up their Conestoga wagons with their logs to build their log cabins. They went to wherever they were going in the Midwest and they started cutting down trees there. They lived off the land. They started growing their food there. They didn't bring it all with them. If they tried to bring everything they needed with them, they would have never made it past the Appalachians. We're going to Mars in the same way.
NASA planners are now looking for other ways to make going to Mars cheaper, if they find them, and if robotic missions provide enough scientific reason to go, they'll have the support of NASA's director, Dan Golden.
It would be my wildest dream. It would be the achievement of a lifetime if I could lead this agency out of Earth orbit and on to places like Mars and asteroids to help us understand who we are and what we are and to enrich life on this planet.
Mission Control, do you copy?
By 9 days into a Mars mission, the spacecraft would be 10 million miles away from home. Earth would have become just another dot in the sky. This far into the journey, the astronauts would still be able to have twice-a-week video conferences with home. But as they get farther away, the time delay would grow longer and more awkward.
I've been thinking a lot about that leak in the family room. And I think we should just go ahead and have the whole roof replaced.
At this point, the delay would be 5 seconds.
Okay, I'll call the roofers tomorrow. He can do the work in a month, which is great. And there's somebody here who wants to say something to you.
I miss you.
I miss you too.
Scientists are developing the technology to recycle air and water for a Mars mission, including a machine that can turn urine into drinkable water. The equipment sits in a 3-story airtight chamber. During the summer of 1996, 4 volunteers put the system through its first real-life test. Sealed for 1 month, they relied on machines to recycle their wastes and to purify the air and water. Everybody stayed healthy. But NASA is also developing another life support system using plants that could be grown on Mars. To test it, volunteer Nigel Packham lived in a pair of airtight containers for 2 weeks. Wheat plants provided him with all the air he needed to breathe. As Nigel used up oxygen and produced carbon dioxide, the plants absorbed the carbon dioxide and produced new oxygen.
Hold on here, let me do the other one again.
The question was, could humans and plants stay in balance? Computers monitored the air in the living chamber, adjusting the amount of light on the wheat plants to alter their production of oxygen.
The plants have performed wonderfully. They react very quickly to me being here and to changes in my metabolic output. For example, if I sit on the bicycle and start exercising for 30 minutes, and I tend to put out a lot more carbon dioxide, the plants react very, very rapidly to that. So it's almost as if they know I'm here.
The plant-based system had passed its first test. NASA's ultimate goal is something similar to what was attempted by Biosphere 2 during the early 1990s. In that experiment, 8 scientists locked themselves up for 2 years to test the feasibility of living in a totally sealed artificial world. Inside were replicas of many of the major ecosystems on Earth. But thorough as they tried to be in reproducing the natural ecosystems of the Earth, the experiment ran into serious trouble. After a year and a half, oxygen had to be added to the closed system because the plants weren't producing enough. And crew members sometimes went hungry. In another experiment, a NASA scientist is taking a much less natural approach to using plants for a complete life support system.
Hi, Greg. Almost ready for harvest this afternoon?
Almost ready.
Here in a chamber just 200 feet square, David Bubenheim has plants growing 10 to 20 times more densely than they do in nature. Rather than imitate real ecosystems, he's manipulating the plants in every artificial way possible to achieve a healthy and steady harvest.
People are going to depend on this for their life. So we're trying to be able to show that we can maintain for an extended period of time all the food, all the air, all the water that a crew needs while recycling their wastes.
The big challenge for closed life support systems is the 2 to 3 pounds of waste that humans produce each day. In Bubenheim's plant system, waste is first sent to a machine that distills out the water, boiling it with excess heat captured from the greenhouse.
The water that comes out of the machine is not quite potable quality. It's certainly much cleaner than the sewage that went in, but it still has some ammonia and some organics in it. And we still have to remove that before it's potable.
The chemicals make perfect plant food, so the almost clean water is recycled back into the greenhouse. As the plants take up the water and grow, they naturally give off water vapor, which is turned into liquid again by condensers that line the sides of the greenhouse. The water has essentially been distilled twice, making it safe to drink.
Oh, that's good.
Thanks to the addition of some artificial nutrients and high-intensity lamps, the plants in Bubenheim's greenhouse grow rapidly and produce tremendous amounts of food. After each harvest, the old plants are replaced. What looks sparse now will be ready to harvest again in just a few days. Over the years, Bubenheim has been able to grow an impressive variety of crops. The food is routinely checked for quality, and every now and then, Bubenheim and his staff cook up a potluck supper. They're now confident they could have their revolutionary plant-based life support system up and running by the year 2005. Based on experience with the prototype, they know exactly how big a system would be needed to support a real base on Mars.
This chamber is about 200 square feet, and for a crew of 4 people, it would be able to supply and recycle all of the air and water, but it wouldn't supply 100% of the food in that case. To do that, you would need an area about 4 times this large, or a chamber about this size per person.
Bubenheim is now experimenting with the color of light to try to reduce the energy needed to run the system.
Well, in all the scenarios we're considering for a space-based habitat, energy is extremely limited. And if we're going to take electricity and make light, we need to use it very efficiently. If you look at these wheat plants that are growing under white light, like plants would outside, where all colors of the spectrum are represented, you can see that there are a number of smaller side shoots that are grown.
Those side shoots are waste that has to be recycled because it's only the taller center shoots that produce grain. But growing the wheat under blue light eliminates the side shoots, leaving the important center ones unharmed. Red light works the same. If the color of light can reduce the waste for crops other than wheat, plant-based life support will become even more attractive. But can a plant-based system work reliably over an entire Mars mission? At least one astronaut fears there could be a crisis, just as there was in Biosphere 2. Story Musgrave.
If there is any form of virus, bacteria, disease, or the plants for some reason become not healthy, then that balance is thrown off and it's fatal.
The kinds of designs that we're looking at in actually building one of these for space would actually provide us some segregation. So if a disease were to come into one section, it could easily be separated and quarantined so that the disease didn't spread to the rest of the plants.
Roger, Mars Explorer 1.
During such a long mission, astronauts would keep themselves busy by working on such projects as the onboard greenhouse. They would have free time between reviewing mission plans. A lesson learned from the Apollo was that what can go wrong will go wrong.
I was driving the only car within 250,000 miles away from home, and I knocked a fender off, which some of my friends think that was probably expected.
Losing that fender left Cernan's rover kicking up so much dust that it threatened his equipment. The mission was in jeopardy if they couldn't build a new one.
We made the fender out of some geology maps that were sort of excess, and we were able to tape those together while they were clean and didn't have any dust on them. We taped 4 of them together, and then we were able to fold them over and extend the length of the fender that I had knocked off over the wheel so that lunar dust wouldn't just get thrown in the air and come down upon everything. That was a very critical fix.
The ability to make repairs in space is crucial, but carrying tons of spare parts into space is impractical. But what if astronauts could call up a computer drawing of a broken part, then build a plastic or metal replacement from the ground up? NASA's working on the technology now, so it should be ready in time to go to Mars.
Start translating up the docking module.
To install spare parts, NASA's entering virtual reality. In the virtual world, astronauts can practice